This lesson covers the IPv6 and IPv4 integration and migration technologies. As your organization adopts IPv6, it'll pick a IP scheme. It could be linked local, stateless or stateful. It may be using site local, perhaps even global unicast. However, you're still going to be primarily using IPv4 and will continue to do so for some time. And so the question will arise, well, how do you link these two different protocols together, and how do I manage that migration? The first item to identify are really the types of node or computers you have in your environment. Are they IPv4 only? Are they IPv6 only? Are they IPv4 and IPv6 capable? What is the network infrastructure in your environment? Can it support IPv6 addressing in terms of your switches? Can they actually route IPv6 traffic, or are they IPv4 only? So you need to understand your network infrastructure, so you're going to work very closely with your network teams. There are protocols here to actually help manage that integration and migration. The first is ISATAP. So ISATAP stands for the Intra-Site Automatic Tunnel Addressing Protocol. So as the name suggests, this is going to allow you to send IPv6 traffic over an IPv4 network. And this is really working by standing up an ISATAP router. So this is a machine, it can be Windows Server 2012. You run a command to enable that box as an ISATAP router. You actually create a host record in DNS called ISATAP, which will then enable all your Windows Server 2012 and older operating systems such as 2008 and 2008 R2 to automatically enable their ISATAP network adapters. So if you actually look at a machine, you'll notice there are ISATAP adapters already available. So if I go through and look at my IP config, you'll actually notice I have an ISATAP adapter, but it's not connected, it's not actually being used. And this is because in my environment, I don't leverage ISATAP. But as soon as you create a DNS record called ISATAP, and it points to the IPv4 address of your ISATAP router you've created, this will automatically be enabled by the client. And this is now going to enable these IPv6 machines to automatically communicate to each other using this ISATAP interface when they're on the same network. When they want to connect to a separate network that's maybe IPv6, that traffic will go to the ISATAP router you have created. It will strip out the IPv6 packets from the IPv4 parent packet and send that on the network. That ISATAP router will also tell via the ISATAP interface those IPv6 capable clients information about the routing and how that traffic can actually be delivered. While ISATAP is a great solution for sending IPv6 traffic across a local IPv4 intranet, it's not a technology that can be used over the internet, which is predominantly IPv4. To send IPv6 traffic over the internet, the 6-to-4 technology is leveraged to actually enable 6-to-4 routers to be placed at each location that are then connected to the internet. And those IPv6 packets are sent via the 6-to-4 router, once again encapsulated in IPv4 that can be sent across the internet, and then stripped out and sent to the target network on the other end of that connection. The 6-to-4 routers also communicate with each other to make sure the routing information is fully populated to enable the correct routing of traffic. 6-to-4 is really the preferred technology over the internet. One challenge with 6-to-4 is that it will not function if the computers are behind an IPv4 NAT device. So for example, if I'm trying to communicate over the internet and my machines behind my NAT will have a private IP address, i.e. within my company, 6-to-4 cannot function. And so Teredo is a solution that enables that tunneling of IPv6 traffic over the IPv4 internet even when it's behind a NAT device. The reality is all of these technologies should really be thought of as transitory technologies. You don't want to maintain 6-to-4 or Teredo, and really the goal is to get to a native IPv6 network. Then this needs to ensure all your operating systems support IPv6. So you're getting into Windows Server 2008 or above, and your applications also support IPv6. You need to ensure your networking equipment supports IPv6 as well natively. So for example, your routers need to support IPv6. Windows Server 2008 and above DNS already supports IPv6 records, but you need to make sure all of your host addresses have AAAA records, i.e. IPv6 mappings, or name resolution will fail. Really focus on enabling that coexistence, and definitely don't just go and disable IPv6, particularly on Windows Server 2008 R2 and Windows Server 2012. There are actually components of the operating system that are purely tested based around using IPv6. So even if you've not manually configured IPv6 in DHCP or on your host, it's still being used by a number of the Windows Server components, and leave its default configuration. And then as you're ready to roll out IPv6 in your environment, it will then continue to function with the addressing and the routing you've manually configured.